Good to have you back. I'm Dr. Sonny, and at this point in time, we'll be considering, and this should be the third introductory part of the lecture. And at this point, we're looking at orthographic projection and pictorial drawing. Very quickly, what is pictorial drawing? This is the kind of drawing you see when you have your picture. It gives more accurate and scientific presentation of an image, just as we'll have it when you have a camera shot. It presents an object from a single view. Uh, it represents the length, width, and the breadth or the depth of the object from a single view, but it lacks the presentation of an object in terms of each views of perspective or elevation. That is, by that I mean, what do you see uh, an object to look at when you stand by the right hand side or left hand side or from the top side of it? So in pictorial drawing, you don't have such qualities, and so it lacks that technical presentation in terms of detailing of the actual look of an object. But in pictorial, we can have detail of an object from a single view as regards to the length, width, and the depth. Now we have different types of pictorial drawing. We have isometric, we have oblique, we have uh, perspective. But for the level we're in now, we're going to stop ourselves in. Though two of them are most commonly used, by that I mean isometric and oblique. But as it pertains to our lecture now, we'll be stopping an isometric drawing. Isometric drawing is the kind of drawing where the vertical plane and isometric plane are arranged in such a way that the vertical plane are always inclined at an angle of 90 degrees to the horizontal, and the isometric axis uh, are usually or lines are usually presented inclined at an angle of 30 degrees or 45 in most cases to the horizontal. And so we have three basic isometric axes, which are arranged in such a way that they are inclined to each other at an angle of 90 degrees. And by the way, I want to explain the difference between isometric drawing and isometric projection. Most times we mix it up, but it's not actually the same. In isometric projection, the isometric axes are inclined to each other in such a way that they are making 120 degrees to each other, but the lengths parallel to them are drawn to full section. They're drawn to full length. But in isometric uh, uh, projection, they are actually drawn to an angle of 120 degrees to each other. But in this case, there is shortening in the length of the lines parallel to them. It's shortened by 0.819%. That means in isometric drawing, the lengths parallel to the isometric axis are in full length, but in isometric projection, the length parallel to isometric axis are shortened by that percentage. Another outstanding difference between both is that in isometric drawing, that is done using normal scale, but in isometric projection, that is drawn using uh, isometric scale, and that brings about the shortening in the length. Very important. So that is the major difference between uh, uh, both kind of drawing. Now, in orthographic projection, this is a situation where an object is assumed to be suspended in a space, okay, in front of two possible orthogonal axes. In front of two possible orthogonal axes, okay. Now, that gives full detail of an object as you want to have it from every side of consideration, whether from the left side or from the right side or from the plan. So in orthographic projection, object that is being suspended in a plane is viewed in such a way that uh, the reflection on any choosing scale, or I mean any choosing plane, whether left, right, or front, is in such a way that the distance between the object itself to the point of reflection on the plane, on the choosing plane, is considered as a projector. Then the reflection itself is called the projection of the object. If the straight line between the object and the point of contact with the plane is in such a way that is aligned at an angle of 90 degrees, That is, by that is normal to the point of contact. It is taken as orthographic projection. Now, this kind of drawing makes use of orthogonal planes, okay? And the vertical and the horizontal are connected to each other in such a way that making an angle of 90 degrees, forming four quadrants. Now, the idea is the two, that is the second quadrant and the fourth quadrant, overlap each other and they cancel out. We're left with the first and the third. And the first uh, angle of projection, which most times is referred to as English projection, and the next one is third angle of projection, which most times is referred to as American projection. Now, there's a difference between both. We don't just call them first and third because we feel like calling them. No, there's something that makes them very unique. In first angle of projection, the detail of an object under consideration is arranged in such a way that the plan is always at the bottom of the front view. That means the front view is above the plan of the object under consideration. And again, very important feature of first angle projection is the uh, the first the left hand view is the count gotten when viewed from the right hand side. I repeat again, the left hand view is the count or the detail when viewed from the right hand side, whereas the left hand view is the detail when viewed from the left hand side. If it's very confusing, if you don't listen very attentively, you'll miss it out. Now I repeat again, in first angle of projection, it is usually arranged in such a way that the first angle of projection the first angle of projection is arranged in such a way uh, the front view is at the top of the bottom plan, and the left hand view is the account seen when viewed from the right hand side, and the right hand view is the account seen when viewed from the left hand side. Now, quickly, third angle of projection, which is also referred to as American projection. Now, this is the kind of arrangement where the plan is at the bottom of the front view is at the bottom of the plan. That means the plan of the object is above the plan view. And the left hand detail or the left hand view is what is seen when viewed from the left. And the right hand view is what you see when viewed from the right. Just a little, just almost opposite of what we have in the first angle of projection. So that is what you have uh, in first angle of projection. Third angle of projection. So we have a little differences because in a short while now we'll be demonstrating it. You know which one is which, and there are symbols we can use in noting that. Very important. There are symbols you can use in noting that, which we're going to demonstrate in the next stage of the lecture. So that is what you need to know about us. Now, in summary, for some of us that did not capture the first explanation, we said that the presentation of drawn objects, usually from the drawing studio, is usually done in either of the two ways, either as orthographic projection or as pictorial drawing. And we said that pictorial drawing is that kind of drawing you see when you view a picture from when you view a picture as though it's done using camera. That is what you do when you have a snap of an image. But it lacks the presentation of an object in more detailed manner in terms of its views, the likes of left, front, and plan. But in orthographic projection, an object can be viewed in detail. It gives comprehensive and technical knowledge of what is desired of any object under consideration. You can view it from the left, from the right, from the top, and the top gives you the plan. And so, and uh, the orthographic makes use of orthogonal planes, which where you consider the vertical and the horizontal employing each other at the angle of 90 degrees, forming four quadrants. The two cancel each other out, that is the second and the fourth, leaving us with the first and the third. And we say the first most times is referred to English projection, whereas the third one is most times taken as American projection. And we said that um, uh, in first angle of projection, the plan view are always at the bottom of the front view, and the right hand side is what you see when you view from the left hand side, and the left hand view is what you see when you view from the right hand side. Then for the third angle of projection, the bottom is always above the front view, and what you view from the side is what you use representing the right hand view, and what you view from the left is what gives account of the left hand view. That's the summary. Then again, we'll talk about isometric, which is an aspect of pictorial. Now, but before then, I said that pictorial could be isometric, oblique, or perspective. But for the stage of the lecture we're in now, I want to stop ourselves in just uh, isometric. And I explained the difference between isometric drawing and isometric projection. In isometric drawing, you draw to the full length, making use of normal scale. But in isometric projection, you draw uh, to shorter scale because you make use of isometric scale. Now, the difference is, okay, the similarity is that both of the angles, axes, which are the isometric axes, are inclined to each other's at the angle of 90 degrees. But for the case of isometric drawing, it is drawn to full length. For this case of isometric projection, it is drawn to shortened length. The percentage usually 0.819 of the original length. That means when you view critically, there is reduction in the length of isometric projection compared to isometric drawing. Now, at every point of takeoff, the vertical height is always inclined at an angle of 90 degrees to the horizontal, whereas the isometric axis, whether to the left or to the right, are inclined to the angle of what? Uh, 30 degrees. In most cases, 45, but most commonly used, as we're going to consider in this our tutorial, we're going to have all our inclination of position at an angle of 30 degrees. Very important. Now, next stage of the work, you need to get close your laptop. This is actually a practical based discussion. I'm only trying to introduce some terms you'll be meeting, will be coming across. So when you come across them, you don't get confused. Very important. So at the next stage of the training, I'm going to tell us. Now, one thing about um, the drawing is drawing with software. Once you do the settings, go to the engineering graphics and software modeling by your friend Otto. I explained very well on how to go about the settings. Once you set it, it's activated, and every of your drawing is done to that isometric projection. But in your manual drawing, you are taught on how to use your two projectors, scale, okay? The protractors and the rest of them. There's one that is to 60 degrees, one to 30 degrees. That was explained in the class when we were doing the manual aspect, but then this time around, just set it up, and automatically you're good to go. I think on page, I think I have it on page 40 of your textbook. Yeah, if I'm not mistaken, page 40 of your textbook explain on how to do some settings and other diagrams I did there. So that is very very essential. And once you set it, you're good to go, and the job is made easy. Now, thank you very much. Please, in your comment box, always tell us. Don't take it for granted. The only reason or only way we can know you're part of what you're doing is by your response to the question that is asked. Very quickly, I want you to write in the comment box what do you understand by asymmetric drawing. Briefly explain orthographic projection. Okay? Don't forget to put your name and your mat number. Okay, thank you. I'll be running up at this stage. Please follow what I'm doing. And I will suggest as well that you practice this manually so that it will make more sense to you as we dive into the next stage, which is the pure asymmetric drawing and photographic projection. Thank you very much, and God bless you.